This is the first lesson of Module 5 in Engaged New York, and Module 5 is the last module that we're going to cover in Engaged New York. So we're almost there. We are starting with Lesson 17 on writing the equation for a circle. And we're doing this for two reasons. First of all, we will take the PARCC exam before we finish this module completely. And there are lots of questions on the PARCC or have been on released PARCC exams that are about this topic. So I want to start with this, so make sure we cover it before you take the PARCC exam. The second reason is in Module 4, we spent a lot of time talking about perimeter using the distance formula. And so I think this lesson provides a really nice link between Module 4 and Module 5. So in this lesson, we are addressing two CCRSM standards, GPE1, where we derive the equation of a circle given the center and radius using the Pythagorean theorem, and GPE4, where we use coordinates to prove or disprove that a certain point lies on a circle with a given center and radius. Let's get started. Lesson 17 starts with the question of what is the length of the segment shown in the coordinate plane below. We've answered questions like this back in Module 4. And again, just like before, we'll use the Pythagorean theorem. So I'll draw in a horizontal length and a vertical length to make this a right triangle so I can use the Pythagorean theorem. This length is 3. And this length is 4, and I want to know the length of the hypotenuse, which for right now I will call r, because eventually this will become the radius of our circle, but that's later on in this lesson. I can use the Pythagorean theorem and show that 4 squared plus 3 squared is equal to r squared. Now, and I can solve for r. And in this case, the length of this segment is 5. Example 1 asks us to graph all of the points whose distance from the origin is equal to 5. So I can go right and up and left and down 5, but in the problem we just did, where the horizontal length was 4, and the vertical length was 4, we found that that was also a length of 5. Okay, so I can use that and also kind of switch the two, that a horizontal distance of 3 and a vertical distance of 4 would also have a length of 5. Okay, so I kind of put those in all the coordinates, then I would find that all of these points are also a distance of 5 away from the origin. So if I were to connect all those points, I get a circle, okay? And it should be a circle because way back in Module 1, we defined a circle to be the set of all points that are distance r from point C, which is what we have here. That distance r is 5 in this case, and the center C is the origin. Now the focus of our lesson today is deriving the equation for a circle. And if I take any point on here, x and y, that came from going from the origin a certain distance x and going up a certain distance y, and I can think about this as a right triangle and use the Pythagorean theorem. And I would find that x squared plus y squared is equal to r squared. Or in this case, that radius is 5. And so the equation of this circle is x squared plus y squared is equal to 5 squared, or 25. All right, let's look at an example where it is not at the origin. And here is example 2 with a circle whose center is at 2, 3 and has again a radius of 5. Okay, now just like before, I'm looking to write the equation of this circle, so I can take any point on the circle, which is x comma y. Now I can't just do x squared plus y squared equals 5 squared, because the triangle I'm looking at is this triangle right here. And this length right here is not going to be x, okay? But it will be x minus 2. Okay, whatever length, whatever x coordinate we are, the difference between that x coordinate and 2 will be the length, the horizontal length of my right triangle. Similarly, that this height here, the vertical height of our triangle, will be y minus 3. Okay, 3 comes from the y coordinate of my center point. Okay, and again, I will have a radius of r because that's the hypotenuse of this right triangle. So I could write an equation for this circle as x minus 2 squared plus y minus 3 squared is equal to, now the radius is 5 squared. Or if I square the 5, I get x minus 2 squared plus y minus 3 squared equals 25. And that is the equation for this circle. So let me generalize this. We generally call the center of our circle HK. I'm not sure why they choose the letters H and K, but that's what's commonly used for these kinds of equations. Okay? The x coordinate is h and the y coordinate is k. So in general, the equation of a circle is x minus h squared plus y minus k squared is equal to r squared. That's the general equation of a circle. And it comes directly from the Pythagorean theorem, where x minus h is the horizontal length of our triangle, and y minus k is the vertical length of our triangle, and r is the hypotenuse of that triangle. Let me give you one example of using that general equation to write an equation of a circle when you're given the center and a radius. So this is exercise 3. You're given a center and the radius. So the general equation is x minus h squared plus y minus k squared equals r squared. And you're given the center, which is 9, 0. So 9 is going to be h, and 0 is going to be k, and the radius is 7. So plugging those in, x minus 9 squared plus y minus 0 squared is equal to 7 squared. And simplifying just a little bit, we have x minus 9 squared plus y minus 0 is just equal to y. So I don't actually need the minus 0 or the parentheses, and I get y squared. And 7 squared is 49. So this is the equation of the circle whose center is 9, 0 and has a radius of 7. Okay, we'll practice a lot more of this during class, and we'll also practice going backwards from an equation and saying what the center and the radius must be if you're given the equation of a circle. This video was an introduction to writing the equation for a circle. Thank you for watching.